So in this video, we're covering 1E, which is talking about what's called a literal equation. I guess I can write that in here. In our class, you guys will get this strip to glue in later. So don't worry about writing this in here. This will be the normal strips that I give you. So to first learn this lesson, we're going to divide our page into thirds like we normally do. All right, I'm going to cut the top 2/3 in half. And in the bottom section, go ahead and pause for a moment and write this definition down. All right. A literal equation is an equation with few coefficients and multiple variables. And so these are examples of literal equations. Everything that you see here that has multiple letters in it. So with literal equations, we're not going to arrive as an answer that is a number. We're going to arrive at an answer that is an equation. It's going to seem a little strange for us. So what I tend to do with literal equations is I actually kind of highlight the variable I'm trying to get by itself. So here in the teacher example, right, it says to solve for b. So I'm highlighting b with a color just to help myself to see what I need to do. All right, so as always, I draw my little river here, and that helps me to remember what inverse operations I need to use. Now this part here, right, I have a fraction that's being multiplied to the parentheses. And so the way that we get rid of that, instead of distributing, we're going to divide by this fraction. And what dividing fractions looks like is it looks like multiplying by the reciprocal. Remember where you flip the fraction upside down with copy dot flip? So on the left-hand side, that reciprocal just shows us multiplying to y right here. Because y is a letter, it's not a number, you can't actually combine it, so it just sits in front of it. On the right-hand side, the two fractions cancel each other out, and you're left with b minus 4. All right, and then if I'm using my inverse operations, right, to undo subtraction, I'm going to add 4 to each side of the equation. Now, the 4 and the y, they can't actually combine because one has a variable and one doesn't. So the way that that looks is it just sits at the end there. And this is actually the end result. So the b is isolated, it's by itself. And everything that wasn't b moved to the edge. And it's the same stuff we did, it's the same inverse operations. They're just sitting together instead of combining into a single letter. Let's do some more examples. It'll make a little more sense. All right, so this one again wants us to solve for b, which is right here in my equation. So I draw my river to help remind me to use my inverse operations. Now this fraction bar that's here, this is saying that I'm dividing by 2. So the opposite, the inverse operation of dividing by 2 is to multiply by 2. So on the left-hand side, a turns into 2a. And on the right-hand side, the b's cancel each other, the 2's cancel each other, leaving me with b. And now that b is isolated, I'm happy. Let's try it again. This one is really, really common, especially in our next unit, just so you know. So be ready for this. So this one wants us to solve for y. This current equation is written in what's called standard form. All right, so if I think about my onion method, all right, there's a 10 touching the y, and then a 3x just a little further away. So I'm going to start by moving the 3x. Now I know that you see this minus belongs with the 10. If it helps you, remember this is a positive 3x. And so to remove that plus 3x that's sitting there, I have to subtract it to move the whole term. Don't lose the negative that's in front of that 10. Now, 24 and 3x, they're not like terms, so I can't combine them. Instead, I just list them separately like this. All right, now looking here, the negative 10 and the y are touching, so that's a type of multiplication. So to counteract multiplication, I'm dividing both sides by negative 10. So this is going to require a little bit of skill with our fractions. Okay, the left side turns into just y. And what we're going to actually be doing is we are distributing, I'm going to write that word here. We're going to distribute the negative 10 to each of these terms. So let's start here. So a negative and a negative will cancel out, so this will be a positive number. And 3/10 as a fraction can't be reduced. So I'm going to call that 3/10 x. Now when I go to distribute here, a positive divided by a negative will come out negative. And if I'm thinking of 24/10, all right, I'm just going to come to the side and show it. They're both even, so I could divide them both by 2. That would give me 12/5. And that can't reduce any further, so I know that I'm good. Would you look at that? Isn't that an equation written in slope-intercept form? The y equals mx plus b? We like that. We like that a lot. That's why we'll use it next unit. All right, one more time. So this one is just kind of a wild function, doesn't it? So we're trying to solve for a. We're trying to get the a by itself. Now the thing that kind of scares kids here is the d and the r and the a and the c, they're both kind of trapped in the fraction. So if I want to try to get a by itself, I have to break apart the fraction first. And how do we break apart fractions? Well, we fraction bust, right? We multiply by whatever's in the denominator. So this one, I'm going to actually multiply times a plus c. So on the left side, that'll end up looking like distribution in a moment. And on the right-hand side, these cancel, leaving me with the d plus r. Now I unstuck the a from the fraction, but now I need to unstick the a from the parentheses. So in order to do that, I'm going to distribute. So on the left side, let me see how much room I have left. Yeah, I'm doing okay. On the left side, I have GA plus GC. On the right-hand side, I still have D plus R. All right, so I'm still trying to get A by itself. Here, I'm going to keep coloring it, highlighting it to help myself see. Like I said, that highlighting really makes life a whole lot better for us, I promise you. All right, so if I think about my onion, right, this GC that's being added is the furthest thing away from the A. So I need to subtract it to move it across the equal sign. Okay, so on the left side, I'm left with GA equals. And these all just kind of get listed a little bit there on the right. And then one last thing I could do here to get rid of the G, I just divide it out, right? Okay, so when I do that, the G's cancel out on the left. And then on the right, I'm left with just this fraction. I have two choices. I could distribute it if I wanted to, but I don't have to because these aren't numbers. These are just variables. So I think the equation looks cleaner if you don't distribute it. Like if I was trying to manipulate the math, I think this would probably be an easier equation to deal with. So I'm going to leave it. But if that g was numbers, like if there were values here, kind of like we had here, they're just numbers, that's when you distribute. So I'm going to write a little note here in red. No coefficients, that means no numbers. So no coefficients means I don't have to distribute. Okay. So there's our main kind of group examples. Down here we have 2 word problems, all right? I'm going to do the one on the left with you, and then you guys are going to go ahead and do the one on the right for me. And when I do your notebook check, that's what I'm looking for, is an exit ticket. Okay. I feel like there's just a lot going on here. I'm just going to highlight my instructions just so that you know what I want. All right. So the formula of an equation of a line in point-slope form, which we're learning about next unit, looks like this. They just want us to solve for the variable m. All right, so we're just going to do, it's going to be real fast. Oh, I don't use red for my river. Okay, so this m is actually pretty easy for us to access. If you notice, it is currently touching the parentheses, which means it's multiplying. So to isolate m, I'm actually going to divide. Now the part that throws kids off is I'm not dividing by m, I'm dividing by the thing that's multiplying to m. So I'm actually dividing by x minus x1. I don't really need the parentheses I'm putting here, but they're kind of my emotional support parentheses, to be honest with you. So that leaves me with y minus y1 over x minus x1. Hopefully that equation looks somewhat familiar to you. That's the slope equation. All right. So now for you guys, as an exit ticket, you guys need to solve for the variable x. So I'd like you guys use the onion method. If you guys struggle with the onion method, there's your onion. I'd like you guys to try to get x by itself and then show it to me in your notes.